Yes, let's move on parameters of the tempering. This is the most important uh, part in this tempering process. If somebody's understood what is exact parameters of tempering, for example, if it is you're the operator of tempering furnace, you should know first. These are the basic 6 steps to be studied first. What recipe has to be made for particular glasses. The one recipe would not be used for all the glasses because all the glasses would be vary. So let's look at it in a different aspects. Let's see. So parameters of tempering. Let's start with the heating time, temperature inside the furnace, glass transfer speed, oscillation speed, distance nozzle in chiller, percentage of nozzle opening on the air pressure which talking about. So these are the main parameters of the tempering. Let's move on heating time. If you are using the convection furnace, heating time would be 40 to 45 times multiplied by thickness of your glass. Radiation types, if you use it, 40 to 60 time, which is T nothing but the thickness of the glass, HT with is nothing but heating time. So this is the thumb rule basic principle, but accordingly, if depends upon the glass output, you have to change the recipe, the heating time accordingly. But when you start testing it, you should know how much normal heating time can be fed as a 6 mm, 8 mm, 9 mm. So basically, you have to multiply into the thickness by heating time. So that's the first simple process you should understand about this heating time. And temperature inside the furnaces. When the temperature goes up, the thickness is down. You see this carefully. You see that which the graphs, the 4. This is the 4 and 10. You will have a range of 700 to 700 degrees centigrade. When move on 12 thickness of 12 mm glass is basically 680. There will be a reduction of 20 degrees centigrade. So basically, when the thickness increases, when the temperature increases, thickness will decreases. So that's the schematic diagram which help us to understand further about this. And again, tint west temperature per mm. Clear glass will be a temperature per mm at 42, whereas the less is blue. So again, this also furnace to furnace vary, but this is the basic principle which we can apply for glass. Basically, why we have to understand this? If you use a clear glass, what kind of temperature per mm you have to put? If you use a green base, as a substrate is different. The clear glass will be a substrate. Green base is a substrate. Blue is again there will be a different substrate, and dark gray is then again other substrate, and gray the other substrate, pink as well. So basically, the different colors would behave differently. So basically, if you use the proper recipe, you'll get a proper result. So glass transfer speed, when the thickness increases, the speed is decreases. For example, 19 mm of thick glass, you have to transfer the speed from one place to other, which means a loading table to this furnace. 19 mm you are using it, so which means your speed is 20 centimeter per second which you use, whereas 4 mm will be 70 centimeter per second. That's what you have to understand. Oscillation speed, which is inside as well as inside the furnace. When the thickness increases, the speed is decreases. For example, 4 mm speed in centimeter per second is 90 centimeter per seconds, whereas 12 mm 85. So there will be a 5 centimeter per second is varies the speed. And again, nozzle distance of chiller. When the thickness is increases, the nozzle distance as well increases. You can able to understand from the graph. From the left hand side, nozzle height, the bottom side the thickness, x-axis, you can see that. Percentage of the nozzle opening. The 4 mm, it's 100% double blower. We have to use it because the lesser thicknesses would absorb the more heat faster. So you require the percentage of opening will be higher. Whereas 19 mm, 10%, but the durability of quenching area time is increased, whereas the percentage of opening will be less. The thickness, 19 mm thickness, 10% of nozzle opening is sufficient. Whereas if you use a 6 mm, normally if you use a 6 mm, we have to use 85% of nozzle opening if you want to have a tempered glass. Whereas if you want to have a heat strengthened glasses, you have to reduce further. Let's move on, bending and tempering process. Now so far we have looked at the flat tempering process. Now we'll move on to bend tempering process. So this is altogether different. This cannot be done on the flat tempering process, where this quenching section chiller portions will be completely different than the horizontal tempering. So heating chamber, the heating is a uniform process, which will be nothing, there is no changes at all in the heating process, only changes in the quenching cooling section alone. So let's move on this. You would have seen that there is a chiller portion which having a lot of fixtures, like it's a movable, flexible fixtures over there, where this the glass has been comes into from heating chamber to this chilling chamber, quenching chamber, where there will be air pressure has been applied with help of the air nozzles over there, and depends upon the bend dimensions, you have to lift it accordingly. The machine can be altered based on the setting. So basically this is not a flat, the heated up the glass, then once comes here, then based on the size of the bend, whatever you want it, accordingly you have to change. Basically this is without tool, you have to change like this, and you have to put the more temperature, put the more air on the top and bottom, that way you are getting the tempered bend glass. You see the bend glass is process happening like this. This is a type of convex which taking place here. It comes out after tempering, there will be unloading table. So the flat tempering as you saw. The second picture is bend, again further than this here also. So different types of bending furnaces are there earlier. So this is the tempering furnace schematic diagram, which is help us to understand the bending process. Bending process types. Bending process is classified into two types: horizontal system and vertical system. Horizontal system comprises the sheets of the glass sets on the horizontal deck, which conveys it through this three phase of the process, which means loading, heating and quenching cooling. That's the three phases. So these are the fixtures. You see the fixtures completely it's not a flat, you can depends upon the radius, the complete portion of your chiller would be changes. This is system which is without tooling, and this is the vertical press. So this is vertically bending, it's taking place. Instead of doing this horizontal wise, this is the vertically, it will be can be done as well. This is the schematic diagram. So these are the types of bend which you can do it. Type 1, the shallow cylindrical bend, curve not exceed 58 degree centigrade, 58 degree. And type B, cylindrical bend, curves exceeds 58 but not 90. Type E, curve plus tangential flat. You can see the one side is flat, one side is a curve, which you can do it. And type F, exceeds 90 degree to 180 bends, it's possible. And type G, double and triple reverse curves, which can be done. And type J, tangential flat plus curve, mostly it's widely used for like tabletops kind of this. And angle bends, which is again it will be used for bakeries, small stores will be used for this angle bends, right angles, and variable angles greater than 90 degree as well, and super G, and followed by irregular curves based on your radius curve, which you can get it out.